Hello, everybody. So we're going to learn another technique of integration now. This one is called integration by parts. And you might remember substitution, one of our previous methods, was related to the chain rule. This one is related to the product rule, but a little bit differently. So let's go back and remind ourselves about the product rule. Suppose I have two functions, both differentiable, f and g, and I multiply them together. I get a new function, and this new function is differentiable, and I can take its derivative using the chain rule. Chain rule looks like this. All right, now let's take antiderivatives of both sides. We're just kind of redoing what we just did, but we're going to do this a little differently. On the left-hand side, when I take the antiderivative, well, I just took the derivative, I get back what I started with. There is a constant of integration we should think about. I'm going to ignore it for now, and I'll address it in a moment. Over here, I get the antiderivative of f prime of x, g of x. I'm taking the antiderivative of this whole side. I can split it up into two antiderivatives, though. And I can do a little bit of rearranging if I subtract the first integral on the right from both sides. And I'll have, what's left here? F of x, g prime of x, dx. And so that constant of integration I talked about, I'm just realizing when I take these antiderivatives, they'll each have a constant of integration, so they're all going to get absorbed into one at the end. So now what we've got here, though, is a nice formula. Let me rewrite it once and just reverse sides, because what we're going to use this for is, I'm writing the left-hand side on the right now. When we find ourselves with an integral of this form, where there's a function times another function that happens to be a derivative, if we can't take that integral with any of the methods we have so far, we can take that function times the antiderivative of the function g and subtract this integral made of the derivative of f, g of x, dx, right? Again, we'll be starting with something on the left that looks like the form on the left. We'll get to decide what is the f and the g in the function we have, and using those, we'll write down what we have on the right here. Hopefully, when we do this, this integral we get on the right, the integral of f prime of x, g of x, is an integral we can solve with our other methods, and so we'll have a result of the integral that we want. So this is what we call integration by parts. Okay, this is the integration by parts formula. Sometimes it's written slightly different. Sometimes you'll see it written as taking u to equal f of x. So du is f prime of x dx, and dv is going to be g prime of x dx, and v is equal to g of x. Well, if that's the case, this formula becomes the integral, the antiderivative of u dv equals uv minus v du. Okay, so it may be easier to remember that way or this way. They mean exactly the same thing. Okay, so let's do an example so we see exactly how this works. Okay, so let's say, give myself a little more space here. Let's say I wanted to take the antiderivative of the function x cosine of x dx. Okay. None of the rules or the techniques we have seen so far will help us here, right? There's no substitution we can make. There's no clever algebra I can manipulate this with. However, if I think of, I'm going to let x play the role of f of x and g prime of x be played by cosine of x, okay? So let's write down what this means. If I take f of x to be x and g prime of x to be cosine of x, then g of x is sine of x, I'm taking an antiderivative, and f prime of x is equal to 1, right? So notice what I did here. I have this integral, and I just named, I looked at the form we have on the right, what I'm going to put in a red box, sorry, the left, I keep mixing up my left and right. I looked at this thing in the red box on the left here in our integration by parts formula and decided what's playing the role of f, what's playing the role of g prime, and I assigned those roles. Given those roles, I can now write down the right-hand side. Let's move these a little. Just going to manipulate this a little bit. So now I know exactly what f and g are. So my first term on the right is f times g minus the antiderivative of the integral of f prime, which is 1 times g sine of x. Right? Again, this is just f of x times g of x minus the antiderivative of f prime of x g of x dx, right? The left-hand side was the integral of the product of f and g prime, right? So I'm just using this formula that we worked out above and deciding for myself who's playing what role. So now, here's where the magic happens. This piece, we don't need to do anything else to, it's done. I also have an integral here, the antiderivative of sine of x, that I now know how to take. This is an antiderivative we can take. The antiderivative of sine of x is negative cosine of x. Now is when I'll put in my constant of integration, and I can simplify this as x sine of x plus cosine of x plus c. Okay? In other words, the antiderivative of x cosine of x dx is equal to x sine of x plus cosine of x plus some constant. Okay? It's a little bit magic, right? It doesn't feel like we ever actually took the antiderivative of x cosine of x dx. Let's see if we at least got the antiderivative through this trickery. Let's take a derivative of what we got. Take the derivative, x sine of x plus cosine of x plus c. We get the derivative of x sine of x plus the derivative cosine of x plus the derivative of a constant. Okay. So this first term takes the product rule. We take the derivative of x, which is 1, and then we leave sine of x alone. We get plus, we leave the x alone and take the derivative of sine. We get cosine of x. We take the derivative of cosine. We're on the next term now. We get minus sine of x. And the derivative of a constant is 0. Notice we have a sine of x and a negative sine of x. So what we're left with is exactly what we began with. This is indeed the antiderivative of x cosine of x. Okay, that's it. That is integration by parts. Saying that's it is a little disingenuous. They can get more complicated. That's it for this one. I'll do some more examples in later videos. These can get certainly can get more complicated. It's not always obvious, right? I made it seem obvious here because I'd already done this problem. What should be f? What should be g prime? If you choose wrong, you might end up with something worse than what you started in this integral that we came up with, right? This worked out nicely. The antiderivative of sine of x is an easy one to do. There's nothing wrong with trying something, getting something you can't work with, and going back and saying, let me try something else. In fact, Not only is there nothing wrong with that, that is highly encouraged. This is how you get good at finding these things. The reason I knew what to choose is because I've not chosen right 1,000 times. Okay, that's it for this one. More to come. See you next time. Thanks, everybody.